Good morning, students. Yes, the last class I started linear PDE, Lagrange's equation. The general form of the Lagrange's equation is capital P small p, capital Q small q equal to R. This is called Lagrange's linear equation, where capital P, Q, R are functions of x, y, z. And then working rule, in step 1, first you need to form the auxiliary equation or subsidiary equation. It is a dx by capital P equal to dy by capital Q equal to dz by R. And then next you should solve the auxiliary equation to find the two independent solutions, u and v. The required step number 3 is the general solution. You should write the general solution is f of u comma v equal to 0. F of u comma v equal to 0, or u equal to function of v, or v equal to some other function of u, where f, phi, g are arbitrary functions. And then there are the subsidiary equation or auxiliary equation can be solved by two different methods. The first method is the method of grouping. The second method is the method of multipliers. Okay, here I explained the method of multipliers. Suppose dx, this is an auxiliary equation. Then by properties of ratio and proportion, each ratio is equal to LDX plus MDY plus NDZ divided by LP plus MQ plus NR. We call LMNR Lagrange's multipliers. It may be constant or functions of x, y, z. And then, okay, now how to choose the Lagrange's multiplier, LMN. So LMN are found in such a way that LP plus MQ plus NR, that is the denominator. This denominator LP plus MQ plus NR is equal to 0. Okay, in such a way that you should choose LMN. So if the denominator is 0, I'll put it again previous. So this is 0, but we know that each ratio is equal to this ratio. From this you can observe that the numerator, that is LDX plus MDY plus NDZ, is equal to 0. So now if we integrate this, we will get the solution u equal to, u is a function of x, y, z equal to a. Similarly, we can find the another set of independent multipliers or independent multipliers LMN or method of grouping. You can find the another solution. Method of grouping is possible, then you can solve by using method of grouping. If it is not possible, then you should use multipliers. Sometimes for both u and v, you can use method of grouping. Sometimes to get u, you can use method of grouping. To get v, you can use method of multipliers. Sometimes for both cases, you need to use method of multipliers. So it's depending upon the problem and the situation. Okay. And then I explained one problem. Now I'll go to second problem. Okay. It's a second problem in Lagrange's equation. Solve. XP, XZP, XZP plus YZQ equal to XY. Okay. So here capital P is what? Capital P is XZ. Capital Q is YZ. Capital R is XY. An auxiliary equation or subsidiary equation. equation is dx by p is x z equal to dy by q is y z. Is my voice is audible?
Yes, sir, you are audible.
Okay, thank you. So dz by r is xy. Okay. Now here I'm not going to use. I'm going to use method of grouping. So now consider the first and the second ratio. That is dx by xz equal to dy by yz. I think you can cancel z and z. So the remaining we have uh, dx by x is equal to dy by y. Okay, now you can easily integrate this. Okay, integrating we get log x equal to log y plus some constant. So I will take that is log a. So log x minus log y equal to log a. So log of x by y equal to log a or x by y equal to a. Actually, this is the first independent solution. That is u of x comma y equal to a. Okay. Now I am going to find one more solution, independent solution. So if I take the first two, so z is you can cancel, and then you can the one side is you have x, the other side is in terms of y, then you can easily integrate. Suppose if you take the second and third, you can cancel y and y, but here have z, okay, but here I have x, okay. Suppose if we have dz by y square instead of xy, if we have y square, you can cancel y and y. Remaining here have y, so you can cross multiply y dy equal to z dz. Then you can easily integrate. So in the similarly the first and the third, the first and third again, if you take the first and third, x and x cancel. Remaining have here have z, but dx by z, okay. But here after cancelling x, dz by y. So here dx, here have y, but here z dz. Okay, z dz is okay, but y dx. So in this situation, you need to be a little bit careful to solve this type of uh, problem. So in this type of situation, you need to use the previous solution. I am going to use the previous solution now. Okay, I will explain you. Consider the first and third. Even you can take second and third also. Dx by xz equal to dz by xy. After cancelling x and x, cross multiply y dx is equal to z dz. From here, from the previous solution, y equal to what? X by a. So now I am going to substitute y equal to x by a. So x by a into dx, the next step, x by a into dx equal to z dz. Okay, now you can integrate because x is one side, another side is z. A is the arbitrary constant. So if you integrate, you will get x square by 2a equal to z square by 2 plus some constant. So everywhere the denominator will have 2. That's why I will write b by 2. Okay. Now, throughout multiply by 2, you will get x square by a equal to z square, that is minus z square. Okay, I'll write one more step, z square plus b. So from this, we have x square by a minus z square equal to b. So this is v of x comma y comma z equal to b. So this is the another independent solution. So step number 2 is over. Step number 3 is you should write the general solution. General solution is f of u comma v equal to 0. So u is x by y. Please check it. X by y. The v is x square by a minus z square equal to 0. But again, for a, you need to replace by a equal to x by y minus z square is equal to 0. So this implies the general solution is f of x by y comma xy minus z square equal to 0. Okay. So if you have any doubt in this problem, you can ask to me. Otherwise, I will go to next problem, third problem. Solve the linear PDE y square p minus xy cube equal to x into z minus 2y. Okay. Now directly write the auxiliary equation. Auxiliary equation. Auxiliary equation is dx by y square equal to dy by minus xy equal to dz by x into z minus 2y. Okay. Now here I am going to use first method of grouping. Okay. First we will try method of grouping. Is not possible, then you can go for multipliers. Okay. If I choose first and second ratio, first, because that is little bit simpler than first and 3 and then second and 3. Okay. Now consider first and second ratio, that is dx by y square equal to dy by minus xy. Now what you can cancel y and y. From this you have dx by y equal to dy by minus x, or x one side, another side is y. So this implies x dx equal to minus y dy. If you integrate, you'll get x square by 2 is equal to minus y square by 2 plus some constant, arbitrary constant a by 2. So now from this we can easily observe that x square you can first multiply by 2, you'll get x square equal to minus y square plus a, or x square plus y square equal to a. So actually this is the first independent solution, that is u of x comma y comma z equal to a. Okay, next consider second and third is better than first and third. Reason is the first and third, if you choose, here you have y square, here x and z minus 2. Okay, you can't cancel anything. But if you choose the second and third, you can cancel at least x. Sometimes a trial and error method only. So you know what is the trial and error method. Okay, it is very difficult to judge which pair is easily give the answer. So now dy by minus xy equal to dz divided by x into z minus 2y. So after cancelling x and x, you have dy by minus y equal to dz by z minus 2y. Okay. So now you cross multiply. What happened? We'll check it. You cross multiply. That is z minus 2y into dy equal to minus y dz. Okay. Z minus 2y into dy, dy equal to minus y into dz. Okay, now z dy, okay, minus 2y dy is equal to minus y dz. Okay, now here you have z dy, z and y. Okay, here y and z. So you should group these two. Okay, here you have y dy. You should keep this one is separated from these two. So z dy plus y dz equal to 2 into y dy. Now you can write this is differentiation of yz. So you should keep y, and then if you differentiate y dz, and then you should keep z, and if you differentiate y, you'll get dy. So this is equal to 2 into y dy. Now if you integrating, you get yz equal to 2 into y square by 2 gets cancelled, plus some arbitrary constant. I'll take b. So yz minus y square. This implies yz minus y square equal to b. So this is a v of x comma y comma z equal to b. So you can easily check that the previous solution and this solution are independent. Okay, so the general solution is general solution is f of a u of x comma y is x square plus y square, and v is yz minus y square equal to 0. Okay, next problem. Solve x into y square minus z square into dx plus y into z square minus x square into dy is equal to z into x square minus y square. Okay, now the auxiliary equation. Auxiliary equation is dx by x into y square minus z square. So please think about the multipliers. Here grouping is not possible. Okay, you should think about what is a multiplier. And if you find, you can tell me the multipliers. Dy by y into z square minus x square. This is equal to dz by r. R is z into x square minus y square. So I need some multipliers, because if you take the first and two or first and three, it is very difficult to integrate, because once you group and then you need to integration. Okay.
Sir,
Yeah, please tell. Please tell.
sir, the question should be in the form of P plus Q is equal to R, no, sir. It's given dx and dy.
Yeah, actually, so you are telling that that p is missing, small p, dou z by p. You are telling p equal to dou z by dou x. Okay, actually, the general form is capital PP plus capital QQ, okay, equal to R. Uh, Okay, here uh, here P is, you should take this is P, small p. This is small q. So even it is of the form dou z by dou x. So this you should take, this is small p and this is small q. So the auxiliary equation is dx by capital P. Capital P is x into y square minus z square, and capital Q is y into z square minus x square, and capital R is z into x square minus y square. Now you should choose the multipliers LMN such that the denominator, so the denominator is this one and this one and this one, the linear combination is equal to 0. So can you identify which I need LMN? Okay, wow, that is a multiplier such that you need to multiply by each term, you will get finally 0. For example, I will write here x into y square minus z square plus y into z square minus x square plus z into x square minus y square equal to 0. So I will write here L, some L, here M, here N. So I need LMN such that this combination equal to 0. So please tell what is L and what is M, what is N. You can't. X, Y, Z. Okay, we will check it. X, Y, Z. You can tell because every time I need to come here and then I need to go to my open board. So we'll check it. X, Y, Z. So if you multiply by here x, you'll get x square into y square minus z square plus m equal to y. So y square into z square minus x square plus n. N is z, so z square into x square minus y square. I need to check it whether it is equal to 0. So x square y square is here, and x minus x square y square is here. Okay, and x square minus z square, x square plus z square. Similarly, here minus x square y square. Okay, minus x square y square, and then I need plus x square y square. Okay, already I choose this one. Okay, so if you write this, you can easily check it. Okay, so x square y square minus x square z square plus y square z square minus y square x square plus z square x square minus z square y square. So you can cancel these two, you can cancel these two, you can cancel these two. So you'll get 0. So x, y, z is multipliers. So actually this is a rough work. So in the exam also, okay, so you can do it in a separate sheet to find the element if it is difficulty. Okay, now I'll go to next page. So multiply by x, so x dx plus y dy plus z dz divided by denominator. So x into So this is x into y square minus z square plus y into y is also there in the question, z square minus x square plus z into x square minus y square. Okay, now so this is equal to, so each ratio is equal to, you should write each ratio is equal to, each ratio means here this ratio and this ratio and this ratio is equal to this ratio, and the denominator is 0. Okay, I'll write one more step, y dy plus z dz divided by 0, and hence we observe that the numerator, that is x dx plus y dy plus z dz equal to 0. If you integrating, we get x square by 2 plus y square by 2 plus z square by 2 equal to sum a by 2. So now your first independent solution is x square plus y square plus z square equal to a. So next you need to find the another multipliers. So if you know the another multiplier, you can tell me. Multipliers. So again, the same thing. You should find instead of x, y, z, you should think about some other multiplier. So just look at here. Suppose without this, if I remove this x and remove this y, remove this z, then you have y square here, here minus y square, here minus z square, here plus z square, here minus x square plus x square. So if you choose L is 1 by x and M is 1 by y and N is 1 by z, so x gets cancelled, y gets cancelled, z gets cancelled. If you add everything, you'll get 0. The multipliers are here. Choose 1 by x, 1 by y, 1 by z. So now each ratio is equal to 1 by x into dx. That is L. This is L, this is M, this is N. 1 by y dy equal to 1 by z dz divided by L is 1 by x. So already you have x into y square minus z square. Please check it. Suppose if I write anything wrong, please point out. 1 by y into z square minus x square plus 1 by z into z into x square minus y square. So you can cancel x and x, y and y, z and z. This is equal to 1 by x dx plus 1 by y dy plus 1 by z dz divided by 0. So each ratio is equal to this one, and hence the numerator is dx by x plus dy by y plus dz by z is equal to 0. So if you integrate this, log x plus log y plus log z equal to some log b. So this implies x, y, z equal to b. X, y, z equal to b. This is the another set of independent solution. So general solution is f of x square plus y square plus z square, that is u, and v is x, y, z is equal to 0. Okay. Next problem number 5. Solve mz minus ny into p. Here nx minus lz into q equal to ly minus mx. So I think here we have explicitly we have capital P and small p, the capital Q into small q. This is R. So now I think for this problem you need to find the multipliers. Okay, so if you find the multipliers, you can get the final answer easily. So if you know the multipliers, you can tell dx by mz minus ny equal to dy by nx minus lz is equal to dz by ly minus mx. So what is the multiplier here? So the idea is, again, I will tell here already lmn is used, that's why I'll use a. Okay, a into mz minus ny plus b into nx minus lz plus c into ly minus mx. So should be equal to 0. So what is a, what is b, what is c? So here you have mz, okay, but here you have LZ. So you should multiply this by L and you should multiply this by M. So that is the hint. Okay. Here have MZ, here have LZ. So when these two are equal, so these two are equal only if you multiply this one by L, this L, and if you multiply this one by M. So that's why I'm going to multiply L, here M. Okay. And then check it here. Here have okay, nx here also minus nx. Sorry, this is yamma. So ly minus mx. Okay, here you have nx, here you have minus mx. You are multiplying this term by m, so you should multiply this one by n. So if you choose a multiplier L m n, so you can get the denominator is 0. So L dx plus m dy plus n dz. Each ratio is equal to, should write L dx plus m dy plus n dz divided by L into mz minus ny plus m into nx minus Lz plus n into Ly minus mx. Okay, now you can see that the denominator is 0 and each ratio is equal to L dx plus m dy plus n dz divided by 0. From this, the numerator is 0. And if you integrate, you will get Lx plus my plus nz equal to some constant. So this implies L dx plus m dy plus n dz divided by 0. So this implies L dx plus m dy plus n dz equal to 0. Integrate to get Lx plus my plus nz equal to the constant a. So now, so if you know the second multiplier, you can tell what is the second multiplier. Okay. So otherwise, again, you need to work out like this, and then each ratio equal to I'm going to choose LMNR here, XYZ. So x dx plus y dy plus z dz divided by x into mz minus ny plus y into nx minus Lz and z into Ly minus mx. So this is equal to x dx plus y dy plus z dz divided by 0. So this implies the numerator x dx plus y dy plus z dz equal to 0. And if you integrate, we'll get x square by 2 plus y square by 2 plus z square by 2 equal to some constant a by 2. So already we choose the a. Okay, it's better to choose b. So b by 2. So the general solution is okay, this implies throughout multiply by 2, you get x square plus y square plus z square equal to b. The general solution is f of what is the first solution? Lx plus my plus nz and x square plus y square plus z square. Lx plus my plus nz and x square plus y square plus z square is equal to 0. So next problem, solve the linear PDE x square minus y square minus z square into p plus 2xy into q equal to 2zx. So the auxiliary equation is here dx by x square minus y square minus z square is equal to dy by 2xy equal to dz by 2zx. So I think here the method of grouping is possible if you choose the second and the third ratio. So by method of grouping, so now consider the ratio second and third ratio. So 2 gets cancelled and x and x gets cancelled. We have dy by y equal to dz by z. Now if you integrating, we'll get log y is equal to log z so plus some constant log a or log y minus log z equal to log a or log of y by z equal to log a or y by z equal to a. So I got one solution. To get the other solution, some method of grouping is not possible here. So that's why I'm going to use first multiplier. So I'm going to choose the multiplier x, y, z. Multipliers, choose the multiplier. X, Y, Z. So each ratio is equal to. So again, here choosing the multipliers is a little bit difficult. So I know that, but this is again by coming by trial and error method. X dx plus y dy plus z dz divided by x into x square minus y square minus z square plus y into q is 2xy plus z into 2zx. But here the denominator is not equal to 0, but the reason I am choosing x, y, z, you can see after finishing this procedure. So x dx plus y dy plus z dz divided by x cube minus xy square minus xz square plus 2xyz square plus 2xz square. If you simplify the denominator, if you simplify the denominator, you get x cube minus xy square plus 2xy square, you get xy square. If you add these two, you get xz square. So I think the denominator you have commonly take x. So you keep numerator as it is, x dx plus y dy plus z dz. So x into x square plus y square plus z square. Okay. Now I will, but you know that each ratio is equal to this ratio. So I'm going to choose dy by the second ratio. Dy by 2xy is equal to the fourth ratio. This is the fourth ratio. So the reason why I'm choosing is here you have even you can choose this one also. So dz by 2zx also you can choose. Okay. So now consider second and fourth ratio. So you know what is second? This is the fourth ratio. So consider the fourth ratio is just now we got it x dx plus y dy plus z dz divided by x into x square plus y square plus z square. The second ratio is dy by 2xy. So cancel x and x. Cross multiply by 2. So 2x dx plus 2y dy plus 2z dz divided by x square plus y square plus z square equal to dy by y. So now you can write the numerator in terms of the denominator is differentiation of x square plus y square plus z square divided by x square plus y square plus z square. So that is the reason I take the multiplier LM1 is xyz, but you need to work out and then you should choose the multiplier xyz. It is not easy to choose directly. Dy by y. Now if you integrating both sides, you get log of x square plus y square plus z square equal to log y plus some arbitrary constant log b. So from this you'll get log of x square plus y square plus z square minus log y equal to log b, or you can write directly x square plus y square plus z square divided by y equal to b. So this is v of x comma y comma z, and then the general solution is f of u. U is, you can please check it, u is y by z, and v is, just now we got it, x square plus y square plus z square divided by y is equal to 0. Okay, now so I'll give some problems to you. Try to solve this problem, and then you can, we will discuss again on Monday. I think our time is so try to solve this problem. Solve x into y square plus z square into p plus y into z square plus x square into q is equal to z into y square minus x square. Second problem, solve y plus z p into z plus x into q equal to x plus y. So we'll do one more problem. Okay, you can try to solve these two problems. Otherwise, we will discuss again this problem on next Monday. Okay. Thank you. If you have any doubts, you can ask to me. I think I gave the correct answer for Magesh Babu. I think Magesh Babu question. So So again, I will check it, and then if it is not correct, then I will give the correct answer in the next class. Okay, thank you.